Hi, in this video I'm going to talk about logarithmic function, the graph of logarithmic function, and domain of a logarithmic function. Okay, so how do we define logarithmic function? Basically, logarithmic function is the inverse of exponential function. Okay, so you know how to find out inverse, just interchange x and y and solve for y. But we have a specific notation for that inverse of exponential function. We write just log for that. Okay, so let's see inverse of exponential function. Let's suppose that y equals to a to the x, where a is greater than 0, is an exponential function, and I want to find the inverse of this exponential function. What do? You interchange x and y, right? You replace y by x and x by y. You got x equals to a to the y, and then you want to solve for y. How do you solve for y? That's where we write this. We use specific notation, right? What you do is the exponent equals to y equals to exponent equals to, you write log of the other side thing x, and that base goes to the base. We write exponent equals to log of the other side, and with base goes to the base. And how do we read it? It is read as y equals to logarithm of x with base a. Logarithm of x with base a. So this is basically the inverse of the exponential function, right? This is the inverse of this exponential function. So let's see how does the graph look like, because you know that the graph of the inverse function is basically the reflection of the graph of the main function about the line that goes through the middle, right? That is y equals to x. So here y equals to 2 to the x is an exponential function. So what would be the inverse of that? That is the logarithmic function. You can see that x is here, in place of a we have 2, right? So y equals to 2 to the x basically. So the inverse is y equals to log of x with base a. So the inverse of 2 to the x will be log of x with base 2. Okay, now how does the graph of this look like? The inverse graph will look like, because since this is the graph of y equals to 2 to the x, the inverse is just the reflection about this line. So the graph will look like this. That is y equals to log of x with base 2. Okay, so let me ask you this. What is the domain of the log x with base 2? So the domain is all the values of x, right? It never crossed the y-axis. So the domain is anything right to 0, right? So domain is 0 to infinity. For y equals to log x with base 2, the domain is 0 to infinity. So can you tell me the range? What are the y values here for y equals to log x? So y values is anything that goes from negative infinity to infinity. Okay. Now you see that domain of log x with base 2 is 0 to infinity. So log x, this log x has domain 0 to infinity, meaning that log is defined only for positive values of x. See, when x is negative or 0, log is not defined. So this is very important thing, okay? So log x is defined for x greater than 0. If this x is positive, then it is defined. Otherwise, the log is not defined. Okay, that is very important thing. We'll see one example here. So we want to find the domain and range of a function. Especially, one of the things that I want to note is, if you want to find range of a function, it is not easy to find range of a function. Usually, if you want to find range of a function, what you do is you find the inverse of that function and find the domain of the inverse. So the domain of the inverse is same as the range of the function, right? For example here, so what is the domain of the 2 to the x? The domain of 2 to the x is negative infinity to infinity, right? Because the values of x can go to extreme left and extreme right. So the domain of this is negative infinity to infinity, which is same as range of the inverse, right? So the domain of the main function is same as range of the inverse, and range of the main function is same as the domain of the inverse. What is the range of this? So the range of this is negative infinity to infinity, but what is the range of the 2 to the x? Is 0 to infinity, which is same as the domain of the inverse function, that is the log function there. Okay, so let's see one more example of that type. So here, find the domain and range of y equals to that. So the domain is easy to find here. For domain, so this log function is defined only if 2x minus 1 is greater than 0. So this must be positive for the log to be defined. Okay, so how do I solve this? Add 1. So you got 2x is greater than 1 and divide by 2. You get x is greater than 1/2. So what is the domain then? X greater than 1/2 means not equals to 1/2. It is greater than 1/2. So 1/2 through infinity. So this is the domain of the log function there. So how do I find the range? To find out the range, so what you do is you find the inverse of that. Okay, so to find out the inverse, we have y equals to log of 3 with 2x minus 1, right? And usually the range of the log function is always negative infinity to infinity. For the range, we find the inverse. To find out the inverse, what you do is you write x equals to log of 3 to y minus 1. So interchange x and y. Interchange x and y. Okay, so x equals to that thing. Now, okay, now let's see, how do I get rid of log here? Let's see here. You can write, if there is x equals to a to the y, you can write the exponent equals to log of the other side with base goes to the base, right? Now you can write this as that way. You mean, if you want to write without using log, write without using log, what you do a to the y, the base to the other side, that is a to the y. A to the y equals to x without log. So let's do that. You write 3 to the y equals to, you can see here, right? So to get rid of the log, what you do is 3 to the x equals to twice y minus 1, and then you want to solve for y. So add 1. So add 1, you get 3 to the x plus 1 equals to twice y, divide by 2. Divide by 2. You got y equals to 3 to the x plus 1 divided by 2. That is the inverse. So we want to find the range of the log function. The range of the log function is same as domain of the inverse function. What is the domain of this? What is the domain of this function? So what values of x are possible here? So x can be anything, right? So x could be negative or positive. So the range is basically negative infinity to infinity. Any values of x is possible. So range of the log function is same as the domain of the inverse function. So the domain is any values of x, right? So here the domain of the inverse function is negative infinity to infinity. That's why range of the log function is negative infinity to infinity. Okay, so these are the final answer for that. Let's see some examples on how do we convert an exponential function into logarithm and logarithmic function into exponent, right? So exponent into logarithm and logarithm into exponent. Okay, we know that from the definition of the exponential function or the logarithmic function, we know that from the definition of the logarithmic function, if you have x equals to a to the y, and if you want to solve for y, then you can write y equals to log of the other side, that base goes to the base of the log, right? Y equals to log x with base a in that case. So can you use the same technique to write, if we know that 8 equals to 2 to the third, how do you write this using log? So it will be exponent equals to, so 3 equals to log of the other side, log of 8, that base goes to the base. Okay, how about this one? 32 equals to 2 to the 5th can be written as exponent 5 equals to log of the other side, 32, that base goes to the base. Make sense? Again, the last example, 3 to the 4th equals to 81. How do you write this? The exponent equals to 4 equals to log of the other side, log of 81, the base 3 goes to the base. So this is how you can write the exponent using log. Okay, the next example is, how do we write log into the exponent? How do we get rid of log? How do we get rid of log? Okay, so this is the rule. if there is y equals to log of x with base a, and if you want to get rid of log, what you do is you do base to the other side. Base to the other side, that is a to the y equals to, you write x without log. Base to the other side equals to x without log. A to the y equals to x. Okay, let me do this example. If you have 2 equals to log of 16 with base 4, how do you write this without using log? You write base to the other side equals to 16. 4 to the 2 is 16, right? Yes. Now how about this? You have negative 2 equals to log of 0.01 with base 10. How do you write this? You write base to the other side equals to 0.01, or you can just write 0.01. That's the same thing. Okay, now let's see this one. So how do you solve this for x? So x equals log of 8 with base 2, right? So how do you write this without using log first? So it is like 2 to the x equals to 8, and you want to solve for x there, right? So how do you solve? Do you remember from the exponential function? There is base 2, there is base 8. So can you write 8 with base 2? Yes. This is same as 8 is same as 2 to the third, right? So 2 to the x equals to 2 to the third. That's 8. So you have the same base, same base on the left and right. They're equal, so you can cancel those. So x equals to 3. X equals to 3 is the solution of this. Okay. How about this one? Again, you want to get rid of log on both sides, right? How do we do that? Base to the other side. That is 3 to the square equals to twice x plus 1. Right? What is 3 to the square? 9, right? So it is 9 equals to twice x plus 1. So how do you solve for x? You subtract 1, you get 8 equals to, let me show it here, 8 equals to twice x, right? And then divide by 2. So you cancel that. So x equals to 4. That's what you get as an answer. X equals to 4. Alright guys.